Hello. 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 Hello.
If you are pushing the sheet, then download to Google Drive.
Then what is the use of joining the class now? Then why I want? Hello. 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 Hello.
Hello.
Hello.
I can't hear Vinod, sir.
I also can't hear.
Am I audible now?
Hey, who is conducting the meetings, man?
Okay, you can exit.
Yeah.
Hello.
Yes.
Yes,
Hello.
yes.
Yeah.
Okay, you can exit from Google Meet and you can join here. No issues.
Hello.
I exited from the Google Drive and I joined here. I didn't understand.
I'll
Like,
repeat.
I
No
didn't
worries.
understand what happened from the last 10 minutes. I mean, like, who is organizing the meetings? I'm like, I think we have to contact them. You know, such an, I mean, like, how come they can take care of? Yeah, sorry. Yeah, please go ahead.
Okay.
So do I need to join in the Google Meet
From
now, or
tomorrow,
do we
this
need to
will
be in
only
this
happen, sir.
online
This
link?
will only
Which one?
go. No Google Meet will work. Okay. First clarity I am giving. From
Yeah.
tomorrow,
Now.
only
Yeah.
this
Okay.
link
And
will go. This
whatever
class
the
link
class
only
is.
will go. No
Okay.
Google Meet work from tomorrow. Okay. And second thing, class will start by
And
7:30. Okay. And third thing, we
okay.
are at initial stage of the class. You may be
To 9:30.
Sandeep, you may be strong with the technical, but I have some freshers. I need to cope up with them as well as I need to cope up with you people. First initial week it will be quite difficult for me. Why? Because I don't have a technical support. I need to take care of everything. You need to understand that.
Hmm. And third thing, I only wanted to ask you, like, see, when tomorrow onwards from here, 7:30 starts, and any issues, I think it's better we start at 7:15 and sort out all
7:15
these kind of issues, and 7:30
7:15
we start
I won't
exact
reach home
class.
at all. That is the problem right here.
So it will be. No, no, I'll talk to the organizers and
Okay,
I'll
okay.
ask them to
See, from
start, and
tomorrow 19
all these kind of
9:40 this
issues,
won't
it
be
will be sorted
happen.
out before
Okay.
you join.
Yeah, I understand you. I understand it. I'll
So
make it
assuming
happen.
that it will happen, and then we'll start by 7:15.
Okay.
So 7:30 we have to be on the class and without all these issues. Because in the class, in the middle, when we are in the subject, we can't able to, from here to here, I can't
Okay,
able to
okay.
concentrate. I'm here in the class, but I couldn't able to follow the class. Then what is the issue? Even though if it is 10 to 15 minutes of class, it has to be without no breaks. It has to be class means class. So whatever
So
I
can
miss
I
now, do I need to
continue?
go to Google and again I have to check? I'm like how I yeah.
सर
Sir,
आप
can
टाइम
you again
दिया तो मैं
explain?
कर सकता
Because
हूँ
we
सर.
can't hear you from 10 to 15 minutes.
Yeah, please.
Just second. Okay. Refrigeration cycle. So refrigeration cycle, why it is called a cycle? Okay, why we call it as a cycle? Because the starting and ending point of the process will be at a same place. Okay, it starts from the same point and ends at the same point. So this is called a cycle, and in the cycle there will be a repetition of the functions. Okay, there will be a repetition of the functions. This is the cycle. And why it is called as a refrigeration cycle? Okay, so in this cycle the refrigerant is circulating. Okay, the refrigerant is circulating, so it is called a refrigeration cycle. In this cycle the refrigerant is circulating, so it is called as a refrigeration cycle. If refrigerant is not circulating, if water is circulating, okay, if water is circulating here, then it is called a water cycle. Okay, then it is called a water cycle. We call it as a water cycle. Okay, now what do you mean by refrigerant? What do you mean by refrigerant? A refrigerant is a fluid. Okay, refrigerant is a heat carrying fluid. Refrigerant is a heat carrying fluid which always changes its phase up on, it always changes its phase upon heat exchange. Refrigerant is a heat carrying fluid which always changes its phase upon heat exchange. Once, if refrigerant is in liquid state, if heat exchange takes place, it can convert into vapor. If it is in a vapor state, if there is a heat exchange, it converts into liquid. Okay, that is refrigerant. So the first air conditioner air conditioner was invented in the year of 1902. 1902. Okay, by a person called Willis H. Carrier. Willis H. Carrier. In 1902, the first modern air conditioner was invented. Okay, and he is called as father of air conditioning industry. He is called as father of air conditioning industry. Now you are able to see in the market. Okay, you are able to see in the market the company. Okay, Carrier air conditioners, that was founded by Willis H. Carrier. So here, as refrigerants, okay, as refrigerants are in the as refrigerants are circulating in this cycle. This cycle is called as vapor compression cycle or refrigeration cycle, basic refrigeration cycle. Vapor compression cycle or basic refrigeration cycle. Now, in this vapor compression cycle or refrigeration cycle, the components are classified into two categories. The components are classified into two categories. One is primary components and second one is secondary components. एक primary component है, एक secondary component. Here, primary components, okay, primary components are more essential to complete the cycle. Okay, primary components are more essential to complete the cycle. Coming to the secondary components are helping components to the primary components. Secondary components are helping components to the primary components. Okay, now what are the primary components and what are the secondary components? Either what are the primary components and what are the secondary components? The components are compressor, condenser, expansion valve and evaporator. Okay, compressor, condenser, expansion valve or evaporator are primary components. Okay. These are primary components. And secondary components. Secondary components are accumulator, axial fan, blower and strainer. Accumulator, axial fan, blower and strainer are the secondary components. Okay, even those are helping to run the refrigeration cycle more efficient. Okay. So all these components are connected with a copper tubes. All these components are connected to a copper tubes. Okay, these are connected with a copper tubes. Hope this is clear. Say yes or raise the hand so that I can understand. Till now it is clear, right? Okay. Now, so basically,
Yes.
compressor is called as heart of the refrigeration system. Okay, compressor we called as a heart of the refrigeration system. In our heart, coming to our heart pumps the blood, right? Same. Refrigeration cycle circulates the refrigerant. Okay, compressor circulates the refrigerant. Now, in the compressor is having some other functions. compressor sucks the vapor refrigerant. Sir, every point is important. I'll stretch every point. Please remember. If you are able to understand this concept, whole air conditioning industry, how it is working, you are able to understand. Compressor sucks the vapor refrigerant. What it is sucking? The vapor refrigerant. And it is compressing. Okay. Compressing the vapor refrigerant. As it is compressing, what it is compressing? The volume of the refrigerant. Compressor sucking high volume of the refrigerant, compressing to the low volume of the refrigerant. Okay. So high volume it sucks, it compresses into the low volume. So you know Boyle's law. Boyle's law, volume is inversely proportional to pressure. Volume is inversely proportional to pressure. Okay. So here it is compressing to low volume. High volume is being compressed to low volume. High volume is being compressed to the low volume. Now, here volume is decreased. As volume is decreased, what is going to happen to pressure? What happens to pressure if volume is decreased? Yes, pressure will be increased. So here
It will increase.
refrigerant will be very high pressure. Very high pressure. Next, high volume to low volume. Next. So Charles' law. The Charles' law is stating that pressure is directly proportional to temperature. Pressure is directly proportional to temperature. When pressure increases, temperature increases. This is very high temperature. Okay. So the refrigerant will be in completely vapor state here. Okay. Refrigerant will be completely in vapor state. So it is called as vapor line. It is called as vapor line. Now, this high temperature, high pressure vapor refrigerant will enter into the series of pipes like a radiator. It will be like a radiator. Series of pipes. Now, from outside, we'll be throwing cold air. What we are throwing? Cold air. So this will be outside the conditioned space. Remember, this will be outside of the conditioned space. So we are going to throw the cold weather, cold air. So suppose in the peak summers, the temperature will be 40 degrees centigrade. Okay, the temperature will be 40 degrees centigrade. Now, as the temperature is 40 degrees centigrade, still we call it as a cold air. Do people still call it as a cold air? With respect to refrigerant temperature.
Yes, because it is high temperature. There is more than temperature will be there.
Got it? Okay. Now, so you'll get hot air out here. So that you'll get hot air out. Now, so here the refrigerant is cooling down. The cold air coming in contact with the refrigerant coil. In the refrigerant, the air temperature will be decreased. So from very high temperature to it will become high temperature. Okay. Now From as as temperature decreases slightly, pressure also decreases. High pressure. So I'm talking with some example assumption values. Suppose if the temperature is 88 degrees centigrade, for every refrigerant, sir, there will be some different properties. So the temperature may come around 49 or 50 degrees centigrade depending on outside temperature. 48 degrees centigrade, I'll assume. Okay. Now here heat exchange is happening. So as the heat exchange is happening, this vapor will convert into liquid. So it is called as a liquid line. Now, this refrigerant will enter into the strainer. Okay, this refrigerant will enter into the strainer. Strainer acts like a filter. Strainer acts like a filter. So what it is going to filter? Why? The complete refrigeration cycle is closed. Do you get any impurities? It is completely closed cycle, right? Do you get any impurities there? Is it possible to get any impurities there? From where you are getting fresh
is it a fresh air or filtered
So is
air?
outside air is directly contacting with
So outside.
refrigerant or refrigerant coil? So the coil is outside, the refrigerant is inside, air is outside. Then how you get impurities into the refrigerant? Is it possible?
Yeah, after
I'm not
that it will
getting.
go evaporator, you know, then you will get the impurity. No. After that, it will go to evaporator coil, right?
No.
So
Okay.
from that
See.
it might be get the corrode. Not, huh? Okay.
Basically, copper joining process is called as brazing. Copper cannot be done with welding. We do copper joining process as a brazing. Brazing is nothing but joining of joining of same metals with another metal. Okay, joining of a metal, two metals or same metal with another metal, not mother metal we are using. Okay. So we'll fill with some another metal which boiling point is completely off of the copper pipe. Okay, so when you are attaching these two pipes, some liquid metal may come out and may settle inside the copper pipe. Is the one chance. Second one is, as this is a copper pipe, okay, as this is a copper pipe, from outside it is well finished. Okay, from outside it is well finished, but from inside it is not that much finished. There may be some metallic rough particles like this. So when the refrigerant is with high pressure, due to the high pressure impact, these metallic particles may come out and may travel along with the refrigerant. So that metallic particles may block the expansion valve. Okay, that is the reason for safety purpose we use the strainer. So after the liquid refrigerant passes through the strainer, it passes through the expansion valve. See, expansion is completely opposite to the compression. It also works opposite to the compressor. What compressor is doing? High volume to low volume, and expansion valve low volume to high volume. Okay, so the expansion is sudden expansion. Suddenly volume, low volume will become high volume. So when suddenly high volume, pressure drops, low pressure. When pressure drops, its temperature drops. Okay, so when the sudden expansion has taken place, low volume of the refrigerant became the high volume, so that sudden pressure drop happens. As sudden pressure drop happens, sudden temperature drops also happens. Very low volume, very low pressure, and very low temperature. Okay, I'll come to the best example here. So do you have habit of using deodorants? How many people use deodorants? Say yes or no. Is it a technical question? So most of you people has a habit of using deodorants at any time of your life. कभी कभी
Yes,
एक
yes.
बार तो use किया था. So now the flip of the deodorant bottle. Okay, the flip of the deodorant bottle is an expansion valve. Okay, is a expansion valve. If I press the flip of the deodorant bottle, okay, if I press the flip of the deodorant bottle, the volume which is present, okay, the volume which is present inside the deodorant bottle is low value. So when I press it, it comes to high value. Okay, it comes to high value. When the medium comes to high value, its pressure is dropped as well as temperature is dropped. So if you spray the deodorant, okay, if you spray the deodorant on your body, what sensation you have? How you feel that? How you feel? Chilled, right? You feel chilled. So same principle, same engineering is happening there.
Yeah.
It's not a rocket science again. Same principle and same engineering here. So what happening? High volume, low volume of the refrigerant, suddenly expanding to high volume. As it is suddenly expanding to high volume, its pressure is getting dropped. As pressure is getting dropped, its temperature is getting dropped. So you get 5 degrees centigrade. Now, so when you spray the particles from the deodorant bottle, how it is coming? It is coming in vapor plus liquid, right? Here also the particles will be in vapor plus liquid. Vapor plus liquid. So maximum will be vapor and minimum will be liquid. Maximum will be vapor and minimum will be liquid. Okay. Now this chilled refrigerant, we will be supplying into the coil. I'm sorry. This coil will be inside the condition space. So everyone can notice this will be outside of the fridge. If you see the fridge carefully, behind the fridge you can see this coil. Inside the fridge you can see this coil. This will be inside the condition space. Okay. Now as it is inside the condition space, the blower, okay, the blower will suck the room hot air. The blower will suck the room hot air onto the coil. So thus this hot air will come and heat exchanges takes place. Okay, this heat exchange takes place so that the hot air will become cold air or comfort air. So before going to tell the comfort air, the hot air will become cold air. Okay, so let's come back to the psychometric analysis. To be in comfort for summer condition, okay, to be in comfort for summer condition, what is the process required? What is the process required? Cooling and dehumidification, right? So here,
Cooling
what
and
is happening first?
dehumidification.
Cooling is happening, right?
Humidity.
Cooling is happening. So we need to get dehumidification also, right? Now, so this 5 degrees centigrade is called a dew point temperature. Okay, what is the dew point temperature? The temperature at which water vapor molecules condenses into the water molecules.
At which
Okay.
molecule condenses.
The temperature at which water vapor molecules condenses to the water molecules. So as it is a dew point temperature, the water which is present, the water which is present here, okay, the water vapor which is present in this air will get dehumidified due to dew point temperature of this coil, and this water will get accumulated, and this water will get accumulated in the drain pan, So you are able to notice in the from the indoor units, okay, from the indoor units there will be a white color pipe, and that white color pipe will be having some water droplets. How many of you noticed? How many of you noticed that water droplets? From indoor units will be having a white color pipe, drain pipe, and the drain pipe is connected outside. Yes, right? That is due to
Yes.
Yes.
Condensing pipe. Yes.
Yes.
Yeah, condensing.
That is due to dew
condensing
point
pipe like that I
temperature.
told.
The water will get accumulated, so which is called as dehumidification. Now we say it is called as a comfort air. Comfort air. Now we say this air is as a comfort air. Now, so again here heat exchange takes place. Again here heat exchange takes place. So as there is a heat exchange here, again what happens? The vapor and liquid will change to liquid plus vapor. Liquid plus vapor. Maximum will be liquid and minimum will be vapor. Maximum will be liquid and minimum will be vapor. Okay. Sorry. Maximum will be vapor and minimum will be liquid. Okay. Now here this is max liquid, minimum vapor. Now this liquid and vapor refrigerant will enter into the accumulator. Okay, liquid and vapor refrigerant will enter into the accumulator. Accumulator separates. Okay, accumulator separates the vapor refrigerant and liquid refrigerant and allows only vapor refrigerant to enter into the allows only vapor refrigerant to enter into the compressor, and it will stop the liquid refrigerant. What is the reason? Can anyone? What may be the reason? Can anyone? Liquids are not having the property of compressibility. Can we compress liquids? Is it possible? Can we compress liquids? Is it possible? No, right? So that is the reason. If we pass the liquids, so it may damage the compressor. Okay, it may damage the compressor. So here we separate liquids and vapor. We separate liquid refrigerant and vapor refrigerant. So vapor refrigerant will get compressed. So here again, this both will be together. Accumulator and compressor will stay together, so that when compressor is working, so the heat from the compressor will be absorbed by this accumulator, and whatever the vapor refrigerant present here, that vapor refrigerant can be converted into, whatever the liquid refrigerant here, that liquid refrigerant can be converted into vapor refrigerant, and that vapor refrigerant also will enter into the compressor to maintain maximum efficiency of cycle. Okay, to maintain maximum efficiency of cycle. This is how the refrigeration cycle works. Okay, this is how the refrigeration cycle works.
Sir,
I'm not
excuse
getting
me,
you.
sir. Once again, can you explain the accumulator? If you don't mind, please.
So accumulator.
Yeah, once again, can you please explain that accumulator? If you don't mind.
Accumulator accumulator separates liquid refrigerant and vapor refrigerant. Okay, accumulator separates the liquid refrigerant and vapor refrigerant. So why we are separating here is, liquids are not having the property of compressibility. Okay, liquids are not having a property of compressibility. As it is not having a property of compressibility, we need to separate. If you are not able to separate that liquid refrigerant will enter into the compressor and compressor gets damaged. Okay, so हमें उसको separate करना पड़ेगा. सेपरेट किया, एक 20% लिक्विड है और 80% वेपर है. वो वेपर क्या होगा, आपके एफिशिएंसी ऑफ साइकिल कम हो जाएगा ना. इसीलिए अक्यूमुलेटर कंप्रेसर के साथ साथ ही होता है. ओके, सो कुछ बड़ा इक्विपमेंट्स में सेपरेट हीटर होता है, नहीं तो छोटा इक्विपमेंट्स में कंप्रेसर से हीट जनरेट होता है ना, वो हीट जनरेट का हिसाब से ही वो लिक्विड रेफ्रिजरेंट क्या होता है, वो लिक्विड रेफ्रिजरेंट वेपर में कन्वर्ट हो जाएगा, वो वेपर भी कंप्रेसर के अंदर चले जाएगा. ठीक है, ओके
Okay, fine.
This is for a generalized split AC or general refrigeration cycle. I didn't get that, Vinod. Okay, any air conditioner in the, for example, can you explain the same scenario
me the
for the split AC?
Okay, I need to tell you split AC, window AC, ductable split,
Okay.
DRV, package. Okay,
Okay, got it.
Yeah, I can understand your eagerness.
Okay. I know, just I wanted to understand this because
Yeah.
not about eagerness. I'm like, one second, please let me alone. I'm thinking that
It is the
that's my
that is the thing
expectation.
I'm
I
telling
have
you.
all this or not.
It
I'm
is
just
the
thinking.
basic refrigeration cycle, which is mother of all refrigeration systems. Okay, even the refrigerator in our home works on this principle only. Okay, I'll come. Those whatever
Okay.
you ask the question split AC,
Yeah.
those are in the line. Today, tomorrow, or day after tomorrow, you'll get that also. How split AC is working based on this principle. Okay.
Okay.
Okay. So the next thing. Hope this is clear, right, everyone?
Okay.
I hope everyone is clear with this. Okay. So once I repeat,
Yes.
just we'll go with a summary. I will take 5 minutes and I repeat this. So the basic refrigeration cycle means
Okay.
it is a repetition of functions where it starts and ends at the same point. Okay. So here the refrigeration cycle having different components, and those components has been divided into two categories. One is primary components and second one is secondary components. Primary components are more essential to complete the refrigeration cycle, and secondary components are required to increase the efficiency of the refrigeration cycle. Okay, here primary components are compressor, condenser, expansion valve and evaporator, and secondary components are strainer, axial fan, blower and accumulator. Okay, and all these components are connected with a copper tube. And in this refrigeration cycle, the medium is refrigerant. As the medium is refrigerant, that is the reason it is called as a refrigeration cycle. So compressor is called as a heart of the refrigeration system. Compressor compresses the refrigerant from high volume to low volume. So as it is compressing from high volume to low volume, so volume is inversely proportional to pressure. So its pressure increases. As its pressure increases to very high, so as pressure is directly proportional to temperature, its temperature also will be very high. So this line is called as vapor line. Now this refrigerant will enter into the series of pipes which is called as condenser. Okay. In the series of pipes, this condenser will be outside of the refrigeration, outside of the condition space. Now to this coil, we'll be throwing outside air. We'll be throwing outside air to cool the refrigerant. Okay, to cool the refrigerant, so that the refrigerants cool down from very high temperature to high temperature, from very high pressure to high pressure. So as the heat exchange is taken place, the basic property of refrigerant is when there is a heat exchange, it changes its phase. So vapor is changed into the liquid. So now this liquid refrigerant will enter into the strainer to get purified with, to get filtered with the impurities. After filtering the impurities, this refrigerant will move into the expansion valve. Expansion valve works opposite to the compressor. Okay, here it is suddenly expanding from low volume to high volume. As there is a sudden expansion from low volume to high volume, there will be a sudden pressure drop. As there is a sudden pressure drop, there will be a sudden temperature drop. The temperature may come around 5 degrees centigrade. And here the refrigerant will be in fluid phase, which is maximum will be liquid and minimum will be vapor. This fluid, the refrigerant, will enter into the series of pipes which is called as evaporator, and this evaporator will be inside the condition space. Now the blower will suck the room air. Room air means hot air, and throw onto the coil. In the coil, there is two things happening. One is cooling and dehumidification. The dehumidification is taking place due to dew point temperature of the coil. Due to dew point temperature of the coil. Now, this after cooling and dehumidification, the air will be comfort, and this comfort air will be thrown into the room. Now, the refrigerant will get heated up again. So from very low volume to very low pressure to low pressure, from very low temperature to low temperature. Okay. So now the liquid, the refrigerant changes maximum will be vapor, minimum will be liquid. This mixture of liquid and vapor refrigerant will enter into the accumulator. Accumulator will separate the liquid and vapor refrigerant. Why? Because to protect the compressor, as liquids are not having a property of compressibility. And this accumulator absorbs the heat from the compressor, and the liquid refrigerant will convert into the vapor, and this vapor is supplied to the compressor to run the cycle, to repeat the cycle. Okay, this is how the refrigeration cycle works. Hope it is clear, right? For a freshers or experienced, one of the
Yes.
most important question, one of the
Yes.
most important question, simply they ask, beta refrigeration cycle explain karo. Simple. So by explaining this refrigeration cycle itself, they understand how much knowledge you have on air conditioning systems. Got it? Types of compressors we have in the market. So this is only, हमें being a design engineer, a types of compressors, types of expansion valves से लेना देना कुछ नहीं. This is only for knowledge. Why? Because we are not designing a machine. We are designing a system. Okay, you need to remember, in the air conditioning field, we are not designing a machine, we are designing a system. Okay, in that system, machines will be the one of the part. Okay, types of compressors: scroll compressor, screw compressor, rotary compressor, reciprocating compressor, reciprocating compressor, and centrifugal compressor. Centrifugal compressor. Next, types of expansion valves. Types of expansion valves: capillary tube, constant pressure expansion valve, electronic expansion valve, electronic expansion valve, thermostatic expansion valve. Types of condensers. So this is condenser. So to the condenser, in the condenser, what is happening? So we are supplying hot refrigerant, and that hot refrigerant, we need to make it cold. So to make it cold refrigerant, what we are doing? We are throwing air, right? We are throwing the air. So now air is cooling the refrigerant, am I right? Is air is cooling the refrigerant here? Yes. So this is called as air cooled condenser.
Yes, correct.
Air cooled condenser. In the air cooled condenser, we have two types again: natural convection and forced convection. Suppose if I kept the condenser like this, if the air is naturally passing through it, which is called as natural convection. Suppose if I am using any axial fan, okay, if I am using any axial fan to throw the air, if I am using any axial fan, then we call it as a forced convection. Then we call it as a forced convection. Forced convection. Next. I'm not telling anything, sir. I'm drawing.
Not you, sir. I'm talking to my mom.
Okay. So we have a coil, and this coil is covered with a shell. This coil is covered with a shell. Now, so we supply hot refrigerant. So what is the output we need to have? We need to have a cold refrigerant. To get cold refrigerant, what I am doing is we'll be supplying cold water here. I'm supplying a cold water. Refrigerant and water is not mixing. Please, you need to understand. Refrigerant is inside the coil. Okay, cold water is outside the coil. So that water will become hot. So what we can name it here? What can we name it here? What?
Fluid cooled.
Yes.
Water cooled condenser.
Water cooled
Liquid cooled
condenser.
condenser.
Water cooled, water cooled.
So this is shell. So this is coil and this is shell. So shell and coil, shell and coil, shell and tube, double pipe are the types of the condensers. Shell and coil, shell and tube, double pipe are the types. Next, types of expansion valves.
Can you please move it
Thank you,
down?
sir.
Move it down. Move it down. And just make a
Types
note,
of
please. Just one second.
evaporators.
Yeah.
Same. In the types of evaporators also. So we have same logic will work out here. So we are supplying cold refrigerant and we need to cool the air here. So we'll get hot refrigerant out. Okay. So we are supplying cold or chilled refrigerant. We need to cool the air from hot air to chilled air or cold air. So now this type of evaporator is called as air cooled evaporator. Here air is getting cooled due to evaporator. There air is cooling the condenser. You need to differentiate the things. Okay, there air is cooling the condenser. Here air is getting cooled due to evaporator. So it is called as air cooled evaporator. Air cooled evaporator. Again here we have natural convection forced convection. Natural convection and forced convection. Same logic here also, sir. Water cooled evaporator. So I am supplying, will be supplying cold refrigerant, will be supplying cold refrigerant, and will be supplying hot water. So this cold refrigerant or chilled refrigerant will make hot water to cold water, and cold refrigerant will become hot refrigerant. So water dispensers, you are able to see the water dispensers in the offices. Okay, this water dispensers will work in this principle only. We'll have a coil, a bowl, and a coil, chilled water coil, sorry, chilled refrigerant coil. Into the chilled refrigerant coil, we'll be supplying the water bubble. That water bubble or water can or water tin will place on the top. So this water will go and will get heat exchange with the chilled refrigerant coil, and this water, chilled water, we are able to drink. Okay, this is the principle. So same shell and coil, shell and tube, double pipe. Shell and coil, shell and tube, and double pipe. So do anyone want to get note of this? Do you want to make a note of this? Refrigeration cycle.
Yes.
Is it done? Refrigeration cycle. Okay. These types of compressors and expansion valves.
Yes.
Done. Types of condensers.
I'm done.
Okay. Types of evaporators. Okay.
Done.
Next. Types of...
Done.
Types of condenser. Can you please once again? 1 minute.
Can you please
Okay.
What?
head after just ahead?
Okay.
Yeah, it's okay.
Types of expansion valves. Just go ahead, please. Centrifuge. Compressor. Types of compressor. Rotary, reciprocating.
Done.
Rotary. Yeah. Centrifuge.
Okay.
Yes. Yeah. This is 1 second. Types of expansion. Expansion. Yes. Done. Yeah. Perfect.
Okay. Next.
Yes, more.
Types of
Yeah.
Refrigeration systems. Types of refrigeration systems. We have two types of refrigeration systems. Direct refrigeration system and indirect refrigeration system. If we go to the real time of the projects, most of the people will make you confused in entire refrigeration system. Okay, be very careful what is direct and what is indirect. In the direct also we have different system, different types of air conditioners. Centralized system बोलता है, centralized non package AC बोलता है. Okay, package AC centralized बोलता है. So different confusions. Don't get any confused. Follow these types of refrigeration systems so that you can understand very clearly. People will in the real time पे people will क्या बोलता है उसको not manipulate, they will discuss. It's not
manipulate.
They will tell you are wrong, completely wrong, but still you make them and explain ye hai. I'll give you clarity in each and every system. Okay. I went to the interviewer. He asked me the refrigeration systems कितना होता है. मैं बोला 2 होता है. So 2 होता है, सिर्फ 2 ही होता है. हाँ 2 ही होता है. क्या है बोलो. This happened in Delhi. Direct refrigeration system होता है, indirect refrigeration. वो क्या है? Direct, indirect. Then I asked, what you know? What is the answer? Windows, split, AHU. वही बोल रहा हूँ मैं. वही direct and indirect. Direct में ये होता है, indirect में ये होता है. So people they don't know into the subject. Okay. So direct refrigeration system means if the air is directly contact with the refrigeration coil, that means evaporative coil. If the refrigeration cycle is directly contact with the evaporative coil, then the system is called as direct refrigeration system. Okay. Compressor, condenser, expansion valve, and evaporator. Compressor, condenser, expansion valve, and evaporator. Now, in this evaporator, if the air is directly coming in contact, then the system is called as direct refrigeration system. Hope this point is clear, right? हाँ 10:30 का
Yes.
Okay, if the air is directly contact with the evaporative coil, then the system is called direct refrigeration system. Excuse me, hurry, water. 20 minutes. Okay, so the air conditioners under direct refrigeration system is window AC. Window AC will be under direct refrigeration system. Split AC. Split AC is having two types: non-ductable split and ductable split. Excuse me. Non-ductable split, ductable split. And ductable split. Excuse me. Non-ductable split, ductable split. VRV or VRF. And finally, package AC. What is VRV? VRF will discuss entire in depth of this session. Every AC, how it works, what are the different components we'll have, I'll discuss. Okay. Coming to the indirect refrigeration system, air will not come directly in contact with this refrigerant coil. So there will be one more cycle again. There will be one more cycle. Now this coil is called as cooling coil. This coil is called as cooling coil. Okay. Now, as it is cooling coil, so what it is circulating? It is circulating. We supply hot water and we'll get the chilled water out. Chilled water back. So now the refrigerant which is circulating refrigeration cycle is called as primary refrigerant. The water which is circulating in this cycle is called as secondary refrigerant. Okay, so in the indirect refrigeration system, first heat exchange takes place. First heat exchange takes place in between primary refrigerant and secondary refrigerant. Okay, primary refrigerant and secondary refrigerant. Later heat exchange takes place in between secondary refrigerant and air. Okay, secondary refrigerant and air. Those type of refrigeration system is called as indirect refrigeration system. In the indirect refrigeration system, we have all air system. All air system. All air system, we use AHU, air handling unit. AHU is air handling unit. Next, we are going to use all water system. All water system. All water system, FCU, fan coil unit. FCU, fan coil unit. Next, we use air water system. Air water system. In the air water system, AHU plus FCU. AHU plus FCU. Okay. So AHU, air handling unit. Air handling unit. FCU, fan coil unit. Fan coil unit. VRV, variable refrigerant volume. BRF, variable refrigerant flow. Variable refrigerant flow. Hope it is clear, right? Hope this is clear. Yeah, you can make a note of this.
Yes.
Yes.
Sir, please maintain one hand notes. Everything what I discuss is completely a short form of your handbook. Okay, handbook का summary version होता है what I am discussing here.
Sir, how can we access the
Tomorrow at
recordings of this
7:15
session?
I'll let you know.
Okay.